Good afternoon to you all. Welcome to the new subject Software Engineering, ITC 3324. First, we are going to discuss about how a typical software project happens in the industry. Let's say you are gathering requirements from the customer. After getting the requirement, the customer need to be described that requirement, how they are going to describe the requirement. This is how they are going to describe what they want. Then after customer giving the requirement, business analyst is the person who are going to identify the requirements from the customer. Okay. After customer described the requirement, this is the way the business analyst understood the requirement. How the architecture design. Then after getting the requirement from the business analyst, architecture need to be designed the system. This is the way that the architecture design the system. Then developers code, how they are coded like this. Then the marketing team describe to the customers how it like. This is the way the software is needed today. Then the project was documented. This is the way the project was documented. Finally, the project is deployed to the customer side. This is the way finally the project deployed to the customer. How the customer build it from their side like this. Finally, it was supported after deployment like this. The customer wants something, but they are getting something. So there is a miscommunication in between all the parties in software development. What is the customer really wanted it? In here you can see from the beginning the customer giving the requirement also wrong. What they want is different. They are giving another way, another description. So the business analyst is getting the requirement in the wrong way and the whole process incorrect. This is the project happens. Can you tell me what is the error in here? There are many errors. The main error is miscommunication in between the customers and the other relevant parties. So here we need to fill this. We need to correct this. That is why we are learning software engineering subject. So learning the software engineering subject, you can be able to identify factors which affect the errors of each phases and you can fix it. Here, these are the overall objectives of your subject. After successfully completion of the module, the student should be able to explain the software engineering principles and techniques to develop the software quality product. Apply software engineering principles and techniques appropriately in developing, moderating complex software systems. These are the main references. All the references you can find in your library. This is how you are going to evaluate end exam 70% and continuous assessment 30%. Okay. Introduction. These are the learning outcomes. Here we are going to discuss what are the problems in software development, understanding the need of why we need to manage a software development, and you can be able to define the software engineering. What is software engineering? Okay, and quality attributes and other classification methods of quality attributes. Software we can be able to divide into two: system software and application software. What is this system software? The system software is the operating system where we load operating system, booting the devices and handling the application software. That is operating system or system software. Then the application software is software, the set of instruction which can be able to handle the user's needs. Example, Microsoft Word, Excel, PowerPoint. Based on the user's need, they are developing software. Here there are some types of software. Here the same thing I described to you. System software is a collection of programs written service to the other programs. There are operating systems, drivers, utility programs, compilers, communication software. The next is the application software. I have already discussed. And the business software. What is business software? Systems have evolved into management information system software that access one or more large database containing business information. That's the business software. Then what is embedded software? Embedded software resides in read-only memory and is used to control product and system for the customers and industrial market. That's the embedded software. Example, washing machine, embedded software. Engineering and scientific software, they have categorized by like using algorithm, they are developing some scientific tasks, engineering tasks. That is the engineering and scientific software. Personal computer software is market-based, like based on the spreadsheet, graphics, multimedia. They are personal computer software. Web-based software, the network becomes a massive computer providing like web-based. It can be accessed by anyone using internet and they are able to connect with. Artificial intelligence software. Software makes use of non-numerical algorithms to solve the complex problems that are not computing straightforward analysis. Hardware and the software, this is how the curves go. With the time, the cost of hardware and the cost of software, can you think about it, how it has been increased and decreased? Here you can see a hardware curve with the cost. Cost has been decreased with the time. The thing is, with the technological development, the hardware improvement is very high and integration and ICs are coming and the cost reduced. Software with the time, it has been increased. Why is that? Because the people are using more and more software to automate their problems, so the software cost is increased. Here the failure curve for the hardware, how the failure is happening in the hardware. Here you can see the failure rate, it has been decreased and finally your hardware is wear out. You are not using anymore the hardware. Okay, because more errors and you want to leave it. Software is engaged or developed or not manufactured in the traditional sense. So the software does not wear out. You can modify and reuse the software. Here the software curve for the Pressman software failure rate. Here you can see failure rate and continues at the same rate until absolute. This is the curve. How the Pressman described. This is the actual curve. In the actual curve you can see there are some changes. The reason behind the changes is when the customer asks for a requirement change, you need to modify it again and again. Then more errors happen, then again it has been decreased, and then again when change, more errors. Likewise, actual curve is different from idealized curve. Okay. These are some surveys which need to find what are the reasons for failures, software failures. IBM is a survey 2000. They found 55% of system cost more than expected. The reason is more cost. And 68 it is over schedule. 88 redesign. There are some reasons. The Bureau of Labor Statistics 2001, they found for every 6 new system put into operation and 2 cancel, probability of cancellation is like 50% for large systems. Average project overshoot schedule by 50%. These are some reasons behind software failures. Okay, in here is example, this is the activity, you have to read and find the answers here. Okay, read and here the main reason behind here the failure is over budget. The next one, by your self-study activity, you can read and decide. Okay, here the over schedule is the reason and the over schedule. Here this is a scenario. The reason is the managers. What is the reason for failure? Is the managers who produced the software they made a terrible mistake of trying to go online without turning the new and old system together for a while. That's the reason. That means parallelly they can be able to run both systems and see the result. If not, it can be a fail. Here the reason is programming testing error. The cause is control by onboard computer, which mistakenly through the rocket needed to cause change because of the numbers. So some programming error. Here in the statistic, we can say that project completion. The 53% of percentage delivered an operation but over budget, over schedule. And 31% is cancelled before they were completed. 16% is on time, on budget. This is how the cost can be allocated in the phases. The requirement capture requirement the most is allocated for 60%, the testing 6%, and others 40%. Out of 40, 14 is for requirement specification. What is this software crisis? This is a very old term. The early 17th, it is categorized by like what are the problems for the software projects, that is the software crisis. Project running over budget, over time. If it is unmanageable, software was not usable, software often did not meet requirements, and also the code was of low quality and difficult to maintain, we can say that is software crisis. Okay, why the software is special from other projects? For example, building a house. How it differs? The main difference is in here the software is difficult for the customer to specify the requirements completely. And also developer's side also difficult to understand what the customer wants. And also the customer requirements changing regularly. And it is intangible one as the other project not tangible, and also testing is very exhaustive and very difficult. The solution is we need to use software engineering. It's a systematic scientific development. You can use case tools to develop the software. You are finding the requirements and formal specification. You can be able to demonstrate like prototype to get the requirement clear, and also free easily understand coding can be used to develop. This is the evolution of software engineering. It has been began in single person activities in 1940 and 1950. It is considered a new scientific discipline in 1960 and 1970. In 1980 and 1990, engineering ideas dominated software development. Then we are going to define what is this software engineering. Simply we can say designing, building and maintaining large software systems. This is Samoil how it defined. The software engineering is concerned with theories, methods and tools for developing, managing and evolving software products. You can read it. Okay, I'm not going to discuss all. This is how we can define software engineering. Use of systematic engineering approach in all stages of software development and project management to develop high quality and economical software using appropriate software tools. Then the software quality attributes. There are two classifications we are going to learn. The first one is Boham's classification. It can be divided into two. current usefulness and potential usefulness. Current usefulness, the quality is expected from a software